I saw this interesting question online where you have 3 congruent circles and it is rearranged or arranged, sorry, in this fashion. And then, so I kind of made this by myself so it doesn't look too nice, not too accurate. However, this is just a diagram. So the point of this question is to find out what this area in blue is. Okay. Now we have 3 congruent circles. Basically, the edge of the middle circle, or the middle circle, it passes through the center of the leftmost circle and the center of the rightmost circle. Okay, so then we have that. Now, if you want to find this area in blue, what I can do first is I can cut it. So here's the center of the middle circle, okay? So I can first find a quarter of it. So this is going to be a quarter, right? This is a quarter of that blue shaded area. So the color in red. So it's just a quarter of it. So if I can find the red area, I just multiply it by 4. Okay. So then the way I will do that is I will first cut this middle circle into a quarter. So this would be 1/4 the area of a circle. So let's say if my circle has radius r, then a quarter of it would be, what is it, pi r squared over 4, right? So, but we don't want pi r squared over 4, okay? We want to find pi r squared over 4, which is all of this area, but then we want to take away this area right over here, okay? That is, I guess, within this intersection right over here. So let's see, how would we do that? What we can do, well, first of all, we need to find the total area, right, of this quarter circle, which we have to be pi r squared, which is the area of an entire circle, and then you just divide that by 4. But then we want to subtract stuff, okay? So, what can we do here? So now let's just take a look at this weird shape. I don't know what it's called, but the base is flat. So let me just use a different color, purple. So let's just take a look at this part right over here. Okay, so notice that if I create a line segment from the red point to this point over here to the blue point, okay, what do we have? Well, notice that this red line, or the line segment, and this, so this is this base line segment, is the radius r, okay? However, from the red point to this point over here, this is also from the center of the middle circle to the circle on the circle, right? So this is also r, right? And then similarly right over here, because they're congruent circles, from this blue point to this upper red point, right? That's also from the center of the circle to somewhere on the circle, which is also the same radius r, okay? Because these are congruent circles. So we have a triangle where all 3 sides are the same. So what we have is we have an equilateral triangle, okay? So that's pretty nice. We have an equilateral triangle. Now, why is that useful? Because we know how to find the area of a triangle, okay? So with an equilateral triangle, however, if I just draw one freehand, so we have radius, 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 but to find the area of the triangle, it's base times height divided by 2. But then what's the height over here, right? What's this height? Okay, so we got to use the Pythagorean theorem. Okay, so we need a 90-degree triangle. So if this is r, then this would be r over 2. This side would also be r over 2. So these are congruent. Okay, I just split the base in half. So I have r over 2 here. So what is the height? The height is going to be the square root of r squared minus r over 2 squared, which is equal to the square root of r squared minus r squared over 4. R squared is the same thing as 4r squared over 4, just common denominator it, which gives me 3r squared square root of, square root of 3r squared over 4, which is the same thing as if you square root the numerator and then you square root the denominator. Square root of 4 is just positive 2. And the square root of 3 is the square root of 3. The square root of r squared is r. Well, you could say absolute value of r, but in this case, r is positive. So it should be absolute value of r, but because r is positive, the absolute value of r is equal to r in this case, since r is greater than or equal to 0. Okay, so that's what we have. The height is going to be the square root of 3 over 2 times r. Now we can use the area of a triangle formula. Area of triangle is equal to base times height. Now what's the base? The whole entire base is r, right? So base times height divided by 2, which equals to r times, well, what's my height? My height was square root of 3 r over 2, but then over 2 again, so that's divided by 4, which is the same thing as root 3 divided by 4 r squared. Okay, so that's what we have. Now, we also have this shape right over here. So this shape right over here in blue. Now, this is going to be kind of like a slice of pizza, right? You're trying to find the area of a circle with this arc right over here, right? That is given by, subtended by this arc, okay? So this area right over here. We know that this angle is 60 degrees or pi over 3 radians. Okay, so we were just trying to find the area of this pizza, okay, with angle pi over 3. Okay, so how do we do that? Well, it's arc length is equal to theta times the radius of the circle. Okay, where theta is just the angle, okay, of the section right over here. We have an arc right over here, but we actually don't need to find the arc length for this question. We're trying to find the area, right? So we actually don't need this formula. The area of part of a circle is going to be 1/2 theta times r squared, I believe. Right? So how do we derive that? So we know the area of this blue section over here, if I call that A, the ratio of A to the entire circle, which is, what is the area of the entire circle? Pi r squared, right? That's equal to the ratio between the angle of this pizza slice, of this part of the circle, to the what? To the angle of an entire circle, which is 2 pi r. Okay, so yeah, I guess right over here, we see it here that the pi's will cancel out. And if I move r squared over, one of the r's will cancel out, so it's just 1/2 theta times r. Good, so that's good to derive these things so you don't make mistakes. Now, once we have that, let us use the formula over here and substitute pi over 3 for theta, which is 1/2 times pi over 3 times r. Okay, since we know this is an equilateral triangle, so this angle over here, this angle is still part of this equilateral triangle right over here. This is pi over 3 times r, which is pi over 2 times 36 r. So this area A here is actually just this part. Okay, so now why is that useful? Because if we take A A, if we take A, right, and then if you subtract the area of the triangle, what you're going to get is you're going to get this black part over here, or this part. It's the same thing. This part and this area, right? This part and this part is the same. They'll have the same area. Okay. So this right over here gives me that the black area. Okay. So this area right over here. Okay. Now, if I know the area of the 1/4 of a circle, which is pi r squared over 4, what I want to do is I want to subtract the area of the blue part, right? Subtract the area of the blue part, which is pi over 6 times r. Okay. Now, that still looks kind of wrong. I still think it's r squared. What did I do wrong in my derivation? So we have the area, pi r squared, is equal to theta to the radius 2 pi, not 2 pi r. The angle is just 2 pi. The 360 degrees, 2 pi. The pi's will cancel out, move the r squared over, you do get r squared. So that's a bit of inting and trolling here in this video, but that is okay. Since, yeah, it's good to reflect on these things, and if there are mistakes caught, you can always go back and check, or I'm just testing you, as my high school teacher would say. Anywho, let's go back. So blue area minus the area of the triangle, so we get pi over 6r squared, so this should be squared, and then subtract area of the triangle, which is root 3 over 4r squared. Okay, we can totally just factor out the r squared, or you can keep it. Okay, so what we're going to do is we're going to take the whole circle, whole quarter of the circle, and then we're going to subtract this cone-like section, this pizza slice area right over here, which is pi over 6 r squared. Indeed, because, you know, this is, I should say, this is like 1/6, right? This is 1/6 of the area of a whole circle. So if I have 6 of these blue parts, I'll get the area of the whole circle. So it's going to be pi r squared over 6. Okay. So we're going to take a quarter of the circle and subtract from it a 1/6 of the circle. However, we're still going to have this black part left, right? This black part over here, which is the same thing as this black part. So this black part over here, what is this black part over here? Well, this black part is going to be this. So what we're going to do is that we're going to subtract this whole entire quantity. So there's going to be brackets around it. So what I'm going to do is I'm just going to distribute the negative sign. So subtract pi over 6r squared, but then I'm going to add square root of 3 over 4 r squared. Another way you can think about this is that what we're essentially doing right here is we're trying to take away the area of this blue part right over here, right? And take away the area of the black part, which is what we have over here. Okay. Another way you can do this is you can take away the area of the triangle, which is you subtract this, okay? But then you also need to take away 2 of these black ones. So what you can do is you can also do pi r squared over 4 and then you subtract the area of the triangle, which is square root of 3 over 4r squared, and then you subtract 2 of these black shaded areas right here. So you have 1 and then 2 of them, right? Because over here you already subtracted the area of this blue triangle. I'll write this a bit neater. And then we need to subtract 2 of these guys. So 2 pi over 6 r squares minus root 3 over 4 r squares. Okay, so if we actually distribute this, what do we have? So this is going to equal to pi r squared divided by 4, subtract root 3 over 4 r squared, subtract, well, this is going to be 2 times pi over 6 r squares, and then plus 2 root 3 over 4 r squares. Okay, and what we have here is that this is equal to pi r squared divided by 4, subtract 2 pi over 6 r squares, and then right here we have a negative root 3 over 4r squared and a positive 2 times root 3 over 4r squared. So negative 1 of root 3 over 4r squares plus 2 root 3 over 4r squares, that gives me positive 1. 1, we only get 1 left, root 3 over 4r squared. Okay, because we have 2 apples here, and then we lose 1 apple here, so we have 1 apple. And right over here, I have 2 pi over 6 r squares, which is what we see right here. We have minus, well, we lose, right? We subtract 2 of them. So we subtract 1 here, and we subtract 1 here. Ultimately, this and that, they're equal to each other. Okay, so I'll just leave it in this form, but I should probably simplify it too. So this is equal to pi over, I'm just going to factor out the r squared as well. So pi over 4 minus, and then this is going to be pi over 3, and then plus what? Plus root 3 over 4, all multiplied by r squared, since I factor out that r squared. Okay, and if I want to have a common denominator, I can multiply top and bottom by 3 here, multiply top and bottom by 4 here, and then multiply top and bottom by 3 here. So we have denominator 12. So ultimately we have, okay, so this is 3 pi minus 4 pi, so that's negative pi, and here I have 3 root 3, okay, and then subtract pi, the negative pi, okay, and then all divided by 12, okay, and this is all multiplied by r squared, or I'm just going to keep the r squared in the numerator. Are we done though? No, not at all, because what we really found was simply just this area right over here. A quarter of it, just a quarter, right? This part over here. We don't want this part, just this part. No, 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 we want 4 of them. Okay, we want 4 of them. So what we have to do is, this implies that the area in question, I'll use this color, area is going to be 4 of these, right? So 4 of these, so 4 over 12 is the same thing as 1 over 3, okay? So we have 3 square root of 3 minus pi, all times r squared, all over 3. Now, I think I'll leave it like that. Yeah, so that's it. The question, the area in question, which is this, essentially just the middle circle, the area of the middle circle that is not within the other 2 circles, right? That is like on the outside of the other 2 circles. This area over here, given that the 3 congruent circles have radius little r, is going to be this right over here.